Hello everyone, welcome to my blog. So today I'm going to take you to the GIS substation. So this GIS was constructed by BPC and Siemens company from India. So this is how signboard is shown in front, and all the civil work has been done by the Ruxar company, which is a private company from Bhutan, and it is surrounded by a big wall like this. You all can see it's surrounded by big wall, and this is how the signboard look like. 400 to 20 and 30, 66 33 kV GIS substation, NIP Norbugang Industrial Park Samchi, in this Bhutan Power Corporation Limited. This is not as BPC. So you all can see the gate here. This gate is automatic gate which is controlled from the control room. This is how wall is constructed, and this LM, which we call as LM, which is used for lightning protection and for lighting during the night time. And this gate is automatic, it's controlled from control room. When signal is pressed, then it will open automatically, and when you want to close, we have to we need to press the close button. And firstly I'm going to show you 400 kV line. This left hand side is incoming line, so RYB is coming from Tala, Bhutan, and this is how the this is the receiving, and this house is GS substation for 400 kV. If you can watch my next videos, I have taken all the parts that are there in GS substation for 400 kV, and this is how it look. And you can go inside and see. Firstly we have web lighting arrestor, web trap, and then it's taken to the bushings, and after that it's taken to the GIS power station. Since this GIS station requires less area, so firstly it's inside the fence. Since signboard is there, it's energized, it's danger zone. People are not allowed to enter without permission in this setup, and you all can see that 400 kV line incoming. And next line, you all can see that this next line is going to Siliguri. It's from here, from this substation, this web trap. We are using only 2 web traps for incoming and 2 web traps for outgoing. So it's for communication. This transmission line voltage will be very high in frequency, so it will be 30 kV to 400 kV frequency will be transmitted in transmission line. When we want to reduce this frequency, only the small 50 Hz frequency is allowed by this web trap to pass through the equipment on this equipment. And this is R, Y, and B. This 3 is going to Siliguri after from this substation. And as you all can see, this is a line coming from Malbase, all the way from Malbase, and it is 220 kV coming from Malbase, and it is transmitted to Damdum substation from here. The 66 kV is transmitted to the factory in surrounding. As you all can see that there are outside this Norbugang, there are 10 industries coming out in future. This is how the substation look like. You can see that thick wall is there. It's where outside boundary for this substation, and chain link fence is there. This is 66 kV. You can see that this is fully charged and sound is produced. RYB, there's 6 line going, and top line where one wire is going from top is known as OPG wire, which is used for protection and communication purpose, lightning protection and communication purpose. And um, this is these are the spare part for transmitting energy during the future. This all wire are undergrounded, and this is recently constructed. And this is 66 kV line. 66 kV line is outgoing line. We are receiving, as you all can see, that we are receiving 220 kV from Malbase. This is a 220 kV from Malbase, and we are stepping down. It's making a hissing noise. You can all can see this fully charged, and this is incoming line 66 kV from Malbase, and it's given here, and it's stepped down, and for industrial uses and other purposes it's stepped down for 66 kV and given out for Damdum and Norbugang substation. Damdum substation. This is how overview of substation look like. This is a GIS substation, and you all can check my first video component inside the GIS substation. I have already shown there. This is how GIS substation look like. You all can see the big transformer, power transformer for distribution transformer and all. This is just overview of substation. In future I'll make the best video and upload. This is recently constructed house and it look new. These are the extra material left over. This is 220 kV energized zone, and this is the receiving, and this is also receiving 220 kV. And I'll take you through again this 400 kV line, and this is how it is stepped down. As you all can see that 400 kV line is stepped down and given to GIS substation. And for 400 kV line we have 4 auto transformer. Now this auto transformer, one is sphere auto transformer and other 3 is for single phase auto transformer for RYB. As you all can see, this first auto transformer, this is second auto transformer, third auto transformer, and last one is you all can see little bit from here. The last one is first auto transformer for R phase, second transformer for Y phase, and this for B phase, and this is sphere for maintenance purpose. And within every 3 months this 400 kV line should be maintained. So this is a GIS station for 400 kV, and then lower part we have 220 kV GIS substation. And as you all can see, this all pump water for fire extinguisher. You all can see this pipeline is for pumping of water. There is a force water pressure at once it will be 8 kPa, so its huge pressure of water will be released if anything fire or any activities occur in this substation. You all can see this house brought, and this is for 20 kV, then above is for 66 kV, and this is for 400 kV, and this 220 kV GIS substation. I'll just briefly take you inside the room. Actually, we require safety and all is charged. This is how it look. GIS substation 220 from 400 it step down to 220, and again 220 we are receiving this breaker, this circuit breaker, this current transformer it's constructed by Siemens company, and this voltage transformer is all inside the GIS room. And you all can see that this is for Malvanse, this is for Tamdum, how it's constructed, you all can see here. Please subscribe my blog. I'm trying my best to do. Current transformer, circuit breaker. Since all are not allowed to enter the substation, so for maintain the temperature and pressure of this room, we have motor system for maintaining temperature and pressure of the room. It's forced air motor temperature, so this is carried out from this here next to this our extra material for future uses. Lightning motion, and you all can see that this transformer for distribution transformer, and this is how temperature is maintained to the next room. No edition, nothing is there in my blog. I'll just upload what I've seen. I'm also OG3 doing it today. On 200 kV we have the transformer here. This three-phase transformer.